summarize again for a moment. I had to differentiate. So 20,000 times e to a function prime is e to the function times the inner function prime, plus the second part, 25,000, e to a function prime is e to the function times the inner function prime. But now I have to continue to do something with this, because I can't simply set it equal to 0. I mean, I would have done the same thing. I still simplify or divide or whatever. But I thought that it would be better if I just change this into the fraction of 1300 over this, because it's a negative exponent, it goes to the denominator. Then I find the least common denominator, which is the only one, right? I need to multiply this by the least common denominator. I copy 660. And when I multiply these two, they have the same base. I have to add the exponents. And that's how I got 0.085t minus 1300. Then, now I'm ready to set it equal to 0 or undefined to find critical numbers. It's never undefined because this will never be 0. It's an exponential function with a positive exponent. In any event, it's an exponential, will never be 0. So now that function v prime can be 0 if the numerator is 0. So 660 e2 equals, I moved it to the other side, and then I divided by 66. So here we are. How do I solve this equation? What do I need to do next? That's not good. Anyone remembers what would be the second or the next step towards solving this equation for t? We looked at these problems.
Take the natural log.
Yes, thank you. Indeed. A sip of water in the meantime. Indeed, we need to apply natural log. Excellent. Thank you. Thank you. So 0.085t equals this number. Don't bother with it. And of course, I have to divide by this. That's why we did chapter 2. Careful how you enter it. You have to put parentheses. So let's take a look. Let's see what we get. So we have natural log of 130 divided by 66 and further divided by 0.085. No, 0.85. Okay, so let's see what we get. I'm going to say 8, approximately. Is 8 here? Yes, it is. It fits in. So this is 0. Now, in the function, I have to plug in 0, I have to plug in 8, and I have to plug in 20. Not before I study the sign left and right. Okay. Now, when I study the sign of the first derivative, there is no point in studying the sign of this because it's always positive. If I enter 0, this is 1. 660 minus 1300, this is negative. Now, if I enter 20, I don't know what I'm going to get, but I'm going to enter 20 and see. I hope that it's positive. So 660 multiplied by e to power 0.085 multiplied by 20, and then minus 1300. Yes, it's 2300. So it's positive as it should be. Now I plug in this ugly function, and then I plug in 0, I plug in 8, and I plug in 20. Okay, this is something like 7.97, I think it was. Okay, 98. So in y equals, I will enter the function, which is 20,000 times e, and the power is 0.033 t, and then plus 25,000 times e, and the power this time is negative 0.052 t, and close. I see the function is entered correctly, I hope. Second table, I need 0. I need 7.98, and I need 20. Okay, what's going on here? Okay, 45,000. Then I got 42,534.55. And then I got 47,532.21. I will now draw my conclusions before I verify whether this row and this row work well together. If they don't, I'll say oops and go back to the drawing board. 45 45,000, of course. Okay, so from 45,000 to 42,000, yes. From 42,000 to 47,000, yes. So I will picture my numbers, basically just their height. I don't care for the ordered pairs, I just care for the height. So here it is, 45,000, going down to 42,534, and then jumping up to 47,532. Absolute minimum, also relative. Absolute maximum, not relative, and nothing. So again, absolute minimum, absolute max, nothing. Exactly as we just discussed. Study the function on a closed interval. We're not graphing it. We are only identifying the absolute max, absolute min, and if the function is decreasing or increasing. Any questions? Any questions? We feel a little bit better about studying a function on a closed interval. Anybody, please? A little bit of algebra.
Yeah, much better.
Thank you. A little bit of algebra was involved here, though. Okay. So far the applications we looked at. We looked at graphing. We looked at graphing a function, studying a function on a closed interval, function on a closed interval. The next application of differentiation is entitled optimization. Optimization. What does optimization deal with? Finding max min. I optimized my investments. Optimization. It's a big branch of mathematics. Huge. So just simply finding max, min of functions. That's what optimization is all about. And this is section 3.5. There is nothing to explain. You'll see in a moment. I'm just going to open on page 328 and we'll practice. You'll see why I'm saying there is nothing. No. 328. Good. So, maximizing area. Maximizing area. Maximizing volume. Minimizing surface area. Minimizing surface area. Maximizing profit. Maximizing profit. Maximizing revenue, and so on and so forth. Let's choose. Maximizing area, maximizing volume, minimizing surface area. Let's choose. We'll have more than one, of course. Maximizing profit. Okay, I will choose 19. And this is on page 329. Let's read the question, the problem. From a thin piece of cardboard 20 by 20, square corners are cut out so that the sides can be folded up to make a box. Okay, so here's 20 by 20. And I have these corners coming out. So then I can create a box that looks like this. Okay, let's read on. So what I cannot forget to do is just write 20 inches by 20 inches. What dimensions will yield a box of maximum volume? Box of maximum volume. What is the maximum volume? Okay. So I know that the squares, we're told that we are removing corners in the form of a square. And the square is unknown, where they didn't tell us how much. So the dimensions of the square, the width of the square is unknown. Okay, no problem. So they're asking us to find the length, the width, since it's a square, they will be the same, and the height. The dimensions of the box with an absolute maximum volume based on the constrictions we have, the restrictions we have. What are they? 20 by 20, that's all we have. We remove corners, and we get a length, we get a width, and we get a height. And we want to determine what dimensions will give us the maximum possible volume. So what is the function that we want to find the maximum for? What is the function that we have to look at, that we want to maximize or find the maximum for? What is the function? Just tell me the name of the function. Let me know if we need to read the question again. Do we need to read the question again? Can anyone tell us which is the function? Just the name, no calculations, nothing. Because we need to establish what function we are looking for first. So which function we are trying to maximize or find the maximum for? What do you think? Anybody, please. Lauren, what do you think?
I'm honestly not super sure.
Can you read this sentence? Not out loud. Can you read this sentence for yourself? And now I'm asking you, which function do you think we need to find the maximum for? I'm sorry that you don't stop me. Everyone, this is for everyone. If there is something is not clear, please stop me at all.
Is it the max function? Or
So what is the function that we have to find the maximum for? Just read this sentence. If you read this sentence, you'll know the answer.
the max volume?
Of course, the function is the volume. Once I've created the volume function, then I will have to find its maximum. This is the key. We're asked to find the maximum volume. So as long as I don't have the function that is the volume, I can continue or I can solve the problem. But once I have a function that represents the volume of the box, then I know how to proceed. Good. So that's our first step. So we know what we're looking for. Good. Can anyone tell us what is the volume, the formula for the volume of this box? The general formula of a rectangular box.
Length times width times height.
And that's it. That's all I needed. Excellent. Good. Now, the height, we denoted it by x. So this is x. But now I have to look at the length and the width. They have to be the same only because I'm removing the same square from every corner. And the foil of aluminum or the cardboard that I have is 20 by 20. Good. So if I remove x from here and x from here, what would be actually the length and the width? Initially, I had 20, but I had to remove x and I had to remove x. So what is the length and also the width? What are they equal to now?
Be 20 minus 2x.
That's it. That's it. And they are the same. So 20 minus 2x, everything squared. And I found a function called volume, and it's a function of one variable. That's it. That was the first step. Again, let's summarize from the beginning. So we're given this cardboard. We are told remove from each corner the same size square, x by x. Create a box. I did. Then they're saying, okay, find the dimensions, the length, the width, and the height in order for the box to have a maximum possible volume. Okay, so I scratch my head and I say, okay, where do I start? Well, I have to start with a function. If I have to maximize this function, I have to start with the function. So the function is the volume. I know the formula for the volume of a box, length times width times height. Very good. Perfect. So now I know that this piece is this piece, which is 20 minus 2x. This piece, which is this piece, is the same 20 minus 2x. And the height is x. I replace the height by x. The same times the same is 20 minus 2x squared. I'm almost done. I have the function. And now I know what I need to do next. What do I need to do next? This is what I need to do next. Find the derivative, see if it's undefined or zero, and find its maximum. That's what I need to continue with. Good. But first I have to square. How many terms we get when we square binomial? This was many weeks ago. How many terms we get when we square binomial?
3.
Excellent. 3 terms. The first term squared minus 2 times the first times the second. So 80x plus the second term squared. Two times 2 is 4. 4 times 2 is 8 with a 0, 80. I distribute x. I distribute x, 4x cubed minus 80x squared plus 400x, always in descending order. And simplify this